Hello everyone. In this video we are going to learn the third lab assignment of the subject Ddco. In the third lab assignment they are given that design Verilog HDL to implement binary adder subtractor, that is half adder, full adder and half and full subtractor. Okay, that we will learn in this video. Now we will discuss about half adder. Here the inputs are A and B, that is 0 0, 0 1, 1 0 and 1 1. Here adding 0 and 0 we will get the sum 0 and carry out is also 0. Adding 0 and 1 the sum is 1, carry out is 0. Adding 1 and 0 the sum is 1 and carry out is 0. Adding 1 and 1 we will get 2, that is we will get here carry out is 1 and sum is 0. Okay, now we will discuss how it works. Okay, if adding 1 and 1 gives 2, then it will be written as here 1 comes and he is 0, that is in binary. Okay, that is here written. Okay, now we will discuss the circuit diagram. Okay, here sum, where there is 1 then we have to choose the inputs and we have to put the gates. Okay, here sum is 1, therefore a bar b, a bar b, a bar b, that is b is coming from here and a is from here, there is not gate, therefore a bar. And here another one, that is a b bar, here a b bar, a is coming from here and b is not b, that is b bar. And there some OR gate between a b bar and b a bar, that will give the sum. And carry out is 1, here 1 comes from these inputs, a is equal to 1 and b is equal to 1, that is ab AND gate, that will give the carry out. Now we will write the expression, that is sum is equal to ab bar plus a bar b. This is the sum equation. And carry out is AB. That's it. Now we will discuss about the full adder. Here the inputs are A, B and carry in. There are 3 inputs in the full adder. Here adding 0 0 0, the sum is 0 and the carry out is 0. And here adding A, B and carry in, the sum is 1 and carry out is 0. Here also same, the sum is 1, carry out is 0. Here the sum will be 0 and the carry out is 1, that is in the previous case we have studied that 1 plus 1 is equal to 2, that is comes to carry out, like that it will come. And now here also the sum is 1 and carry out is 0, carry out is 1 and sum is 0. Here also same, carry out is 1, sum is 0. And here there will, it gives carry out 1 and sum is 1, that is it is 2 to the power of 1 and it is 2 to the power of 0, that is here it will give 2 and it will give 1, 2 plus 1 is equal to 3, like that. Okay, now we will write the K-map for carry out. Okay, here there is 1, C in 1 and B is 1 and K is 0, that is K is 0, both are 1 1, it will come here. Okay, and here A and C in are 1, B is 0, that is B is 0, C in and 1, A is 1, here comes. And this will give A is 1 and B is 1 and C in is 0, A is 1, B is 1 and C in is 0, that is here A is 1, B is 1 and C in is 1, that is here. Here we can group these two and these two. Okay, and naming for this is here B, A is not changing, therefore A, and B is changing from 0 to 1, but C is not changing, C in. Okay, naming for this is here A is not changing, and here B is not changing, that is B, and C in is changing from 1 to 0, therefore we are not writing C in. Okay, and the naming for this is, here A is changing but B and C are not changing, they are same, therefore B and C in. Then we have to write it in equation. C out is equal to AC in plus AB plus BC in. That's it. K-map for sum comes like this. Therefore, we will not pair anything. We will pair like single. Okay. It cannot be paired. And this will be written in equation as sum is equal to A XOR B XOR C in, like that. Okay. Circuit for full adder comes like this. Okay, here it is AB XOR and C in XOR, that will give the sum as in the equation here. Okay, and carry out is here AB AND gate, C in AND gate, and BC in AND gate, that will combine together like this here equation. Okay, this will give the carry out. Now we will discuss about the half subtractor. Okay, here the inputs are X and Y. There are only two inputs. Here 0 0 0 1 1 0 and 1 1. Here 0 and 0 difference is 0 and borrow out is 0. Here 0 1 difference is 1, borrow out is also 1. Here 1 0 difference is 1, borrow out is 0. And here 1 1 difference is 0 and borrow out is also 0. Okay, the circuit diagram for half subtractor will look like this. Here xy bar and x bar y will combine together to give the difference, that is AND of x and y bar and AND of x bar and y. These outputs are combined in OR gate and this will give the difference, that is here we can look here difference here x bar and y and xy bar, x bar and y and xy bar and x bar and y, that will give difference, and bar out is y x bar, that is here y x bar. That's it. Okay, now we will discuss about the full subtractor. Here there are three inputs as like in the full adder. Here the 0 0, x is 0, y is 0 and borrow in is 0, then the difference is 0 and the borrow out is also 0. And in the second input x is 0, y is 0 and b in is, that is borrow in is 1, then that will give the difference 1 and borrow out is 1. And in the third, difference is 1 and borrow out is also 1. Here the difference is 0 and the borrow out is 1, and here the difference is 1 and borrow out is 0. Here the difference is 0 and borrow out is also 0. Here also the same, and in the last difference is 1 and borrow out is 1. Okay, now we will see the K-map for borrow out. Here borrow out is 1 and that is b in is 1, x and y are 0, that is x is 0, y is 0 and b in is 1, that is here. Then next borrow out is 1 here, y is 1, other all 0, y is 1 here and other are 0, that will come here. Okay, and the next x is 0, other are 1, x is 0, other are 1 here, y and b in are 1 and x is 0, and the next last output all are 1, that is 1 1 1, that will come here. Okay, then now we have to pair them, these two pairs and these two pairs. Okay, this will be named as y b in, because y and b in are not changing, x is changing from 0 to 1, and for here x is not changing, that is 0, that is x bar, and y is also not changing, y is 1 to 1, therefore y, and b in is changing from 1 to 0, therefore we will not write that. Okay, and here this we will write here. Okay, here x is not changing, that is 0, therefore x bar, and here this pair y is changing from 0 to 1, then we will not write that. Okay, b in is not changing, that is 1 to 1, therefore b in, therefore the whole equation becomes y b in plus x bar y plus x bar b in, x bar b in. Okay, now as in the full adder, full subtractor also difference we cannot pair, therefore here these are single pairs, and we will write it as x XOR y XOR b in, that's it. Okay, the circuit diagram for full subtractor will look like this. Okay, here x, y and b in XOR, that will give the difference, and for bar out we will have y b in AND gate, x bar y AND gate, and x bar b in AND gate. These are combined together with the OR gate, like here. Okay, or combined together to get the bar out. Okay, now we are writing Verilog HDL program for half adder and subtractor. Okay, half adder and subtractor. First module name is given as half adder and subtractor. Inputs are a, b and sum will come, carry is come, carry out, and difference and bar out. These are outputs and inputs are a and b only. Okay, here input a, b, output sum, carry out, difference and borrow out. First we will see the half adder. Okay, this is comment. Okay, half adder, this comment will not be taken in the execution. Okay, we have to assign the values. Assign sum is equal to a XOR b. Okay, and assign carry out is equal to a and b. Okay, here this can be also be written as a XOR b, and this carry out is ab, that is here written. Okay, semicolon, and we will write half subtractor. We have to assign the values. Assign difference is equal to a XOR b. Here also the same. The equation comes same as sum for the difference, therefore the same equation is written here. And assign borrow out is equal to, here borrow out is x bar y, that is a bar y, that will be written as, this is a bar and y is b, that's it. Okay, now end module. This is for half adder and subtractor. Okay, Now we will discuss about the writing the Verilog HDL program for full adder and subtractor. Okay, full adder and subtractor. Here we will write module. Module name is given as full adder and subtractor. Inputs are A, B, sum and carry, difference and borrow out. Okay, here inputs are A, B and here we will write C in and borrow in as inputs also. Okay, we have to write here inputs is C in and B in. Okay, A, B, C in, semicolon. Output is sum, carry out, difference and borrow out. Okay, then now we will assign for sum. Okay, first full adder we will write. Okay, assign sum is equal to what will be the equation that we will know here. Okay, sum is A bar A XOR B XOR C in. Okay, that we will write here. Okay, A XOR B XOR C in, and assign carry out. What will be carry out? Carry out is here AC in, AB and BC in. That is A C in or A B or B C in. That's it. Okay, then now we will do full subtractor. Assigning difference is equal to what will be the difference? That is difference is X XOR Y XOR B in. That is A XOR B XOR B in. That will be written as here A XOR B XOR B in, and assigning for borrow out. What will be the borrow out? Borrow out is Y B in. That is Y means B here, B and B in. Here X is A, that is A bar B plus here X bar means A bar B in. That we have to write here. Okay, first A bar B, that is A bar B or A bar B in, A bar and B in. That's it. Then we have to end the module. End module. That's it. Okay.